Simple machines make work easier to do. Use a wedge or a lever or a pulley or a screw, a wheel and axle or an inclined plane. They're all simple machines, are simple machines. A wedge starts wide but is pointed at the end. A lever's like the seesaw that you ride on with a friend. A pulley is a wheel with a rope that goes around. Wherever there is work to do, you know what will be found. Oh, simple machines make work easier to do. Use a wedge or a lever or a pulley or a screw, a wheel and axle or an inclined plane. They're all simple machines, all simple machines. An inclined plane helps you move things up and down. A wheel and axle helps things move or turn around. A screw is like a screw. Oh, come on, hold on, wait a second. Or the lid of a jar. Without simple machines, we couldn't get too far. No, simple machines make work easier to do. Use a wedge or a lever or a pulley or a screw, a wheel and axle or an inclined plane. They're all simple machines, all simple machines. Simple machines make work easier to do. Use a wedge or a lever or a pulley or a screw, a wheel and axle or an inclined plane. They're all simple machines, all simple machines.
Okay, class, after watching this video, what do you guys think of simple machines? Obviously, I'd start out by asking the class this question after watching the video. I'd ask them what kind of simple machines they have seen in our world. Then I'd probably tell a joke or say something funny. I'd come up with an idea, like maybe asking the class if they'd ever heard of Mr. Pulley, whose job it was to climb up the flagpole every day. He'd had to climb up the flagpole and put the flag at the top of the pole, obviously, until he came up with the idea of the pulley system. He used that system to raise the flag without having to climb up there every day, and this pulley made his job and life much easier. And that's how the pulley came up, and I'm sure they'd get a couple giggles or laughs out of the class.
What am I doing?
I'm already recording.
Oh wait.
Hello class. Miss Laura's going to pass out the index cards that will all contain each group's simple machines. If you have any questions, you can ask her or I. Take a few minutes. We're going to all get on the class computers and figure out things about their simple machines. As I mentioned before, the students would finish this project by speaking in front of the class, explaining each of their simple machines and kind of talking about why they thought these would impact the world and why their little models could be scaled to something bigger that would impact the world. I think that this is a good way for all the students in the class to learn about the different simple machines. And then this would be a building block to our final assessment, which would be homework for the students. I would give them each a rubric that is attached with my lesson plan. This rubric would explain the paper they're going to write for this assessment. It would just be a page long, half a page for those that had trouble writing or may have struggled with the assignment. This paper would need to include many things. It would need to include each person's personal reasons for adding in the details they did to their project, the group project, and it would explain why this project, the simple machine, would impact the world. It would also talk about why they thought us drawing to scale, making the projects bigger to have an impact in the world, would be important. The drawing to scale part is obviously the math part of my lesson, mine and Laura's lesson, and this part is very key in the whole lesson because it kind of gives the students the reason why it's important to the world. Instead of just a little assignment they did in class, a project that would be fun, it would open their eyes maybe and explain, why is this important to the whole world? How can we change the world? Which is something that we always want our students to do, think outside of the box. My lesson would be 2 to 3 days long, take a couple class periods, but I would use this one as the first of the 3 because it kind of gets the children hooked, hopefully, on the assignment and the lesson of simple machines and drawing to scale. After I had Miss Laura pass out the index cards to the students, we both would kind of explain the idea of what our project would be, which is building our own simple machines. The students would be in groups of 4 or 5, and they'd each have the index card that would tell them which kind of simple machine they would be building. Following that, I'd give them time to work on the classroom computers, use some technology, which I'm sure they enjoyed being in a group discussing, which kind of simple machines would be neat and how they could use the classroom materials given out to build these simple machines. Following that, I'd ask each group to dedicate a person to each job. We'd have a writer who would record data and kind of go step through step and copy down why they did the steps they did in this building. We'd have a builder who would build the simple machine. We'd have somebody to help out in all areas, and then finally we'd have a person to explain why they did this later on in the lesson plan. Following that, we'd give the students probably 30 minutes or so, about half the class period, to work on this, making their blueprints, building their materials, their simple machines obviously, and then I'd get the class together to kind of do a class discussion. Not too much pressure on the students, because I was one of those kids that didn't like the pressure, and most students don't, but the public speaker would enjoy that, and he'd get up there with his group and explain why they built the way they did and why these materials were put in their simple machines the way that they were.